Hello, so this is my video response assignment regarding the topics of elasticity, plasticity, Hooke's law, and elastic constants. I firstly started my learning experience by getting a brief idea about the mechanical properties that determine the behaviors of materials, as well as understanding that when a force is applied to a material, its response is majorly determined by the nature of the bond and the structural arrangements of atoms. After getting a brief idea of the mechanical properties, I went on to understand and characterize the four different types of deformations that occur in a material. The first one being elastic deformation, where deformation vanishes when the force is unloaded. The second one being plastic deformation, where permanent deformation occurs. The third one and the last one being viscous deformations, where it occurs in non-crystalline solids and dependent on time, as well as steadily deforms under stress. After defining these four different deformations, now I was able to characterize or idealize the materials depending on these deformations. The first material was elastic material, second one plastic material, third material elastic plastic material, where both elasticity and plastic deformation occurring. The fourth and the last one being viscous elasticity material, where both viscous deformation and elastic deformation occurring. Furthermore, I understood that depending on the crystallographic directions, material can be separated into two types. The first type being isotropic materials, where the mechanical properties or the material behaviors are same in all directions, and the second one being anisotropic material, where the material behaviors are different in different behaviors. Lastly, I ended this chapter or this topic by understanding the Hooke's law and its linear relationship between stress and strain. After ending and understanding the isotropic materials and the different deformations occurring in material, I was able to characterize the four different types of elastic constants in isotropic materials. The first one being modulus of elasticity or Young's modulus, or it can also be defined as the stiffness of a material. It is when if axial force in compression or tension is applied to a material, and it's defined as the ratio between stress or into strain. The second one being Poisson ratios, and it's the ratio between transversive strain into longitudinal strain, usually in negatively. I also understood that the Poisson ratio value cannot exceed 0.5 in isotropic materials, and this is according to the theory of elasticity. Therefore, nevertheless, I went on to the third elastic constant in the isotropic materials, and it's the shear modulus, and it is the ratio between the shear stress into shear strain. And the last material or the last elastic constants was the bulk modulus, or the ratio between hydrostatic pressure over its volumetric strain. After getting a brief idea and understanding the four elastic constants deeply, I was now able to solve equations regarding these topics. After that, I now am able to understand the relations between these elastic constants and their respective formulas and their formulas respectively. Lastly, I ended my learning experience by understanding the characteristics or the characteristics of modulus of elasticity, which are as follows: the high in covalent compounds, lower in metallic and ionic crystals, and lowest in molecular amorphous solids, usually as plastics and rubber. Thank you everybody for listening to my video response assignments. Hope I covered everything.